Okay, this is exercise number 22 on page 25 of the book Elementary Differential Equations by Rainvill and Bedient, 7th edition. Now, this is an example or an exercise for separation of variables. We solve the differential equation xy plus x dx equals x squared y squared plus x squared plus y squared plus 1 times dy. First, we are going to simplify this. The left side will have a common factor of x, so that we have y plus 1 inside the parentheses times dx equals, on the right side of the equation, the first two terms have a common factor of x squared. So the first two terms will have y squared plus 1 inside the parentheses, and then plus the remaining two terms, y squared plus 1. It's this and this. Okay? All of this to be multiplied by dy. Okay, so let's copy the left side first. Equals. Okay, so if we group the last two terms here, we will have this one, y squared plus 1 plus, we group this, we'll have y squared plus 1 also times dy. So this is common factor also, so that the right side of the equation, common factor of y squared plus 1, and what's left is x squared here, and here is just 1 times dy. Okay, so we cannot separate the variable. All functions of x will be coefficients of dx, all functions of y will be coefficient of dy. So we will multiply the whole equation by 1 over y plus 1 over x squared plus 1. Okay, so left side becomes x dx over x squared plus 1 equals, right side becomes y squared plus 1 over y plus 1 dy. Left side of the equation, we can integrate this, but the right side, let's simplify further. So let's copy first the left side. Okay. So if we are going to add 1 and subtract 1, we're actually adding 0. So it's not changing the numerator. So we add 1, we subtract 1, it's the same as we're adding 0. So the purpose of that is to have a term y squared, using this one, minus 1, plus, if we add this, we get 2 over y plus 1 times dy. Okay? So let us copy the left side first, x dx over x squared plus 1 equals, the first two terms here, this one and this, is actually the same as y plus 1 times y minus 1. Okay? Then plus 2 over y plus 1 times dy. So let's continue copying this one. We will integrate that one later. Okay, so we can group this, okay, as y plus 1 times y minus 1 divided by y plus 1 plus this one is 2 over y plus 1. All of this to be multiplied by dy. Okay? X dx over x squared plus 1 is, this one will cancel, and we have y minus 1 here plus 2 over y plus 1 multiplied by dy. Okay, now we can integrate. This is just if we let u equals x squared plus 1 and du is 2x dx, and we only have x dx here, meaning we need a neutralizing factor of 1 half. Okay, 1 half of du over this one to be u equals, here this can be written as y dy minus dy plus 2 dy over y plus 1. So the left side of the equation is 1 half of the ln of u. This one is y squared over 2. This one is negative y. And the last term is just 2 times the ln of y plus 1, then plus c, or we'll use ln of c. Okay, so it's just a matter of simplifying this one and substituting back the value for u, which is x squared plus 1. Let's copy that here and multiply everything by 2. We will have ln of u equals y squared minus 2y plus 4 times ln of, we can combine this one, that can be written like this, c times y plus 1. That's according to the law of logarithms. Again, u is x squared plus 1. So u is x squared plus 1, and we will have ln of x squared plus 1 equals y squared minus 2y plus 4 times the ln of c times y plus 1. Okay. So that is the answer. You can check the answer of that. It's also in the book, exercise number 22, page 25. Okay, here's an alternate solution after you have this. Okay. Instead of doing this one, we will do long division. Okay, so we have y squared plus 1 divided by y plus 1. Okay, so using long division, we have y squared plus 1 divided by y plus 1. Or we can move this one over here, because if we multiply y times y, we'll have y squared, y times 1 is plus y. Subtract, we have 0, this is negative y. Bring down 1, we have plus 1, and then we multiply negative 1 to get negative y. Negative 1 times y is negative y. And negative 1 times 1 is negative 1. And if we subtract this is 0, while this one is 2. So therefore, this is equal to y minus 1 plus the remainder 2 over y plus 1. Okay? So this is actually the same as this one. Okay? So again, and then we will have the same answer.